that'd be awesome. And whenever you guys are ready. Charles, it says you're unmuted, but we can't hear you.
Yeah, I apologize. I had my microphone off. Thank you, Nicole and Chris. Today, Resiliant, which provides a complete end-to-end zero trust product suite. It's a end-to-end zero trust with an identity control and access management. Today, Paul Swinton, our Vice President of Engineering, will be presenting, as well as myself, the Chief Product Management Officer of Resiliant. I'm sure everybody's received a lot of history through other presentations, but just quickly, you know, our understanding that the history of this really started back with in 2007 with the Defense Information Systems Agency, DISA, under the Global Information Grid Black Core Network Initiative. Later on, the software-defined perimeter framework was refined by the Cloud Security Alliance to be able to control the access resources based on identity of individuals. Resiliant was a principal technical contributor and co-author of the CSA working group throughout that time frame, and helped to define the open source SDP specification in conjunction with DISA. Resiliant continues to work with NIST, ATARC, as well as GuideTech, the Government Information Technology Executive Council, to advance the capabilities of Zero Trust going forward. Just an overview, executive overview of what we're going to be going through, but you know, what we see today, Zero Trust certainly is the future. It's been given a lot of boost by the presidential order 14,028. We have seen a significant pickup in need and requirements from organizations since that announcement. The challenge that is presented to organizations today is that fixed network perimeters are no longer effective. They do not really secure the digital boundaries necessary where businesses need to protect the assets of their organizations across multiple clouds and users located anywhere. Our vision is really to be able to provide solutions that really live up to the vision of never trust, always verify. No network is implicitly trusted. We need to be able to provide a continual verification of each user and device and application and transactions. We have built and delivered the next generation digital identity. We refer to this as ID NFT. It's a digital anonymous representation of an individual in the form of a hash and shares the same characteristics as a non-fungible token. It has security and identity uniqueness, and it's stored in a digital, a private blockchain. We'll be going into more details on this later on. So what if there was a way to protect every entry point into the network and only allowed authenticated users to access specific services? That sounds ideal. Well, that's really the goal and capability of an end-to-end zero trust solution. The facts: VPNs and firewalls are failing, perimeter-based security solutions are failing. It's not sufficient to be able to just look at people from a perimeter-based solution. And as we all know, ransomware attacks continue to increase on a rapid pace over the last few years. Firewalls and VPNs have not kept pace with the growing perimeterless networks, and organizations are deploying and supporting today, especially given that there are a far larger number of users seeking to access the highly sensitive applications and services contained within these perimeterless networks that are seeking access through the internet as well as enterprise networks. Zero Trust is the solution to a perimeterless net environment. The way to solve this at Resiliant is through an end-to-end zero trust solution. This is the combination of an identity credential access management plus zero trust zones. This encompasses everything from end user to specific applications and or services, and the ability to be able to define who has access to what, when, where, and how. We believe there are two components to an end-to-end solution. They are identity credential access management, ICAM, which is the basis of any zero trust solution, and trust zones, which is the ability to cloak or darken sensitive applications and services, thus ensuring only authorized users, verified end users, are permitted access to the protected applications and services contained within the zero trust zones. This slide shows you the 12 ATARC scenarios as defined in the vendor presentation outline. Resilient is able to address all 12 ATARC scenarios with our Resilient end-to-end zero trust solution. Today we'll be demoing scenario 1 and scenario 2. You can see from the legend in the diagram that Resilient has a true end-to-end zero trust solution. The identified areas in green are core capabilities of Resilient zero trust. And the first two columns referred to as ICAM, the user and device endpoint, we have significant capability within those areas. The other 5 network areas or core pillars are capabilities of Resilient zero trust end-to-end solution as well. But the yellow indicates what we integrate with, and the purple indicates what is on our roadmap. This is our end-to-end architecture, which is comprised of 3 components: the Resilient ID Thin app, which is installed on the mobile phone; the gateway, which is a Ubuntu virtual machine and can reside in a cloud or on a customer premise. The third is a Resilient zero trust controller. This is also a Ubuntu VM and can reside in the cloud or on a customer premise. Paul, are there any elements you want to go into more detail on?
Well, I'd just like to point out that the controller is where we do our policy definition. It's written right there in blue above it. And the gateway is where we actually enforce that policy.
Excellent. This is our end-to-end zero trust architecture, which is this is the first part, pillars 1 and 2, known as ICAM. This is where we identify the end user attempting to be able to gain access is the true end user on an approved device. And before we grant access to a protected application or assets contained within the zero trust zone. This is depicting the second half of our end-to-end zero trust solution, pillars 3, 4, 5, 6, and 7. And we refer to this as Resilient zero trust. Here we're establishing the zero trust zones that are darkened and specific designated applications or services to be protected. Thus, you can see from the slide, in the previous slide, we were able to provide strong identity credential access management combined with a zero trust zone of protection, such that organizations can now define at a granular level who has access to what, where, when, and for how long. It's important to note that we separate the ICAM portion from our end user solution from the access to the protected applications or services, such that they do not share the same connection. In other words, after a user has been successfully authenticated, the connection's broken and a separate data path is established, connecting the end user to the requested application and or service. So this is the first part of the demo that I'm going to be showing for you, and it's going to be focused on the ICAM portion of our Zero Trust solution, referred to as Resilient ID. The ICAM portion, or Resilient ID, consists of two parts. The first part being an onboarding process of the end user and their device in an absolutely verified manner. And the second part I will be demoing for you will be the verification of the end user and the device into the trust zone. Before we get into the demo, it's important to understand a lot of the steps that will be taking place through the onboarding process. The first step is really the user will be taking a picture of a government document using their cell phone. This is using a driver's license, a passport, a state identification, state ID, and this government document will be tested against a large database of over 10,000 documents for authenticity. We need to ensure that there are no forgeries being attempted. The user will then take a selfie. A liveness and bias tests are applied at that point. We'll be getting into more detail on liveness and bias and how important that is. We will compare the selfie to the picture of the government ID for a match to be able to determine a positive verification. When we do a match and we know the user is the individual who is attempting to onboard is in fact the real person. We will then extract the UUID from the device, the geolocation from the closest cell tower, along with key characteristics of the government document that was utilized, such as the state, city, the family name, as well as other key features of the picture of the individual that was taken. Their eyes, their nose, the geometry of their face. And all of that is run through an algorithm that creates a very unique string, which is then hashed using SHA-256. This hash is also known as an ID NFT that I referred to earlier. The hash we will then store in a private blockchain to be able to be used later on. We also store the original government ID that was used in the first step here on the user's phone or device in an encrypted state. We encrypt using AES 256. And the original government document is only stored in an encrypted state on the user's phone and nowhere else. And this is giving them complete control over the user's privacy and their personal identifiable information. This is done for later verification during the live authentication process. As I mentioned earlier, we have both liveness and bias testing within the onboarding process, as well as the access into systems. The Resiliant has been tested by two labs, both accredited by NIST and certified biometric testing capabilities. The first is iBeta Labs, and we were tested in 2020 for liveness. Liveness is the ability to be able to ensure that there's a valid live person in front of the camera. It's looking for characteristics and ensuring that there are no deep fakes, there are no pictures being utilized to try to fake out the actual person in front of the camera. iBeta attempted over 1,500 attacks utilizing their presentation attack detection mechanism, and there was a 0 success rate of attack. Big C Labs in 2022, earlier this year, performed both a liveness and bias test on our technology. and confirmed that our product exhibits fairness in terms of bias for targeting demographic groups, including gender, age, and race. They also provided a liveness detection, and it passed as well with a success rate of 0. Liveness detection is very important and is considered essential to be able to prevent spoofing attacks where biometrics are used for digital identity verification and authentication. I will do the start the demo for the onboarding here. Here we go. Onboarding of the Resiliant ID is a very simple process. Onboarding is performed once and takes less than 30 seconds. We create a unique blockchain digital ID and don't upload any information of the user or of the government ID to a secure, to our secure private blockchain servers. It equates to no risk of hacking, 100% respect of users' information, and 100% security. The blockchain-based ID that we refer to as the ID NFT, it's trademarked and patent pending because we share with the NFTs a non-fungible token, the same security characteristics. It's unforgeable, unique, indivisible, anonymous, and interoperable. Non-fungible means that it's unique and can't be replaced with anything else. For example, a Bitcoin is fungible. You can trade one for another Bitcoin, and you'll have exactly the same thing. A one-of-a-kind trading card, however, is non-fungible. For a Resilient ID, onboarding again is very simple. The user initiates the Resilient app. You are immediately asked to provide a government ID, a driver's license, a passport, or other government ID. Here, we've selected the ID, a passport in this example. You place the phone over the passport, fit it into the document in the frame, and wait for the border to turn green. Resilient ID detects automatically the type of document and if it contains a chip. You will then be prompted to place the phone over the document as it is shown in the animation and wait until the chip reading process is completed. Next, you'll be prompted to take a selfie. Once Resilient ID has examined the photo for liveness and validates against the government ID, determining you are who you say you are, a unique blockchain digital ID called ID NFT is created and uploaded to the secure private blockchain. All right, so next we're going to have Paul demonstrate the capabilities of the utilizing the admin console to be able to create zero trust zones.
All right. Let me have the screen there, Charles. I'll take it from here.
There we go. Sorry about that.
All right. So as Charles said, I'm going to go over our administration console, which basically allows you to administer and manage the environment once you have it set up in your either in your private cloud or in your on-prem installation. To do that, we'll just move over to my development machine, or my demo machine, I guess is a better way of saying that. And if you see, this screen is our welcome screen. This is our home screen for our administration console. It's a little sparse right now, but the idea is that what we have on your home screen is basically your trending information and the things you want to know about. Closed and open connections are definitely paramount on that list. So we just add those here for demonstration purposes. We'll walk through the menus going towards the right, from left to right. The next menu that we want to look at is our gateways. Now, as Charles mentioned to you earlier in the presentation, is that the way that we define our zero trust capability is to be able to set up these trust zones. And the trust zones allows us to hide the available applications and assets behind our gateways, making them undetectable and undiscoverable. So what you see here is a pre-setup of one of our trust zones we have in our demo environment. We've decided to call it Trust Zone 20. That's just a reference that we use internally to figure out who can go through where. Obviously, that's the host IP address next to that, which is the IP address of the virtual machine. And then we have a SPA port. If you are used to or have heard of SPA port, single packet authentication, that's what we use to actually be able to receive a request and authenticate a device over a SPA port. So that port is undetectable as well, but our gateway listens to that. Going down to the right, you see the services protector. These are the services that we've set up behind the gateway. So these are hosted on multiple virtual machines or physical machines, but these equate to services that we've made available to this trust zone. And then we have credentials. The idea behind credentials is you're able to easily configure a gateway in the field and set up a new network on the fly. The idea is that you spin up the virtual machine, you copy the credentials, and once you copy the credentials, those are available for sending via, I don't know if you wanted to send, if you just wanted to send it to the browser, you can download, you can see that it's got the trust zone number and the zip, and it's in a zip format. So you can download it to the browser, or you can actually send it over a text message or any other means of delivery, which simplifies the method of actually standing up a new trust zone and configuring a new gateway. We also utilize APIs at this level and throughout the controller's interface to enable you to do such things as bulk unloading. So it could be very tedious if you're setting up a very large environment and deploying multiple gateways. You certainly wouldn't have to want to do one gateway at a time. But by utilizing our APIs, you were able to do more than one at a time. If you wanted to set up a new trust zone, it's just as simple as clicking our Add New Gateway. We want to create a new trust zone. Obviously, we want to have the IP address of the new gateway available, so we need to know how to route things. So I'll just, for our sakes here, we'll just do a fake IP address. And then we have the port. This is that SPA port. Again, single packet authentication port. This is the port that our authentication, encryption, and certificate information is exchanged with the gateway to ensure that the device that is trying to contact us is actually a device that we know. So again, we'll just set up just some random port just to make sure it's there. We'll say it's valid, and then we'll say wrong port number. Then we'll say save. Now, just that simple. We have our new gateway set up. It's ready to go. You notice we have a lock here to credentials. We haven't generated that credentials yet. But before we generate those credentials, what we want to do is say, okay, we have a new trust zone that we want to set up. What services do we want protected by that trust zone? Well, that's what this little blue plus sign here does for you. It adds a rule for protecting services. So what you do is you say, okay, I want to add a new rule. And the services that are available are just going to be the services that we've defined. These are obviously a small set of what you can do. These are the ones I've defined for our demo purposes. So you would pick one or more of those. I'm just going to say one for now. And we'll say whether or not it's going to be TCP or UDP. What the accept port is, this is the port that the gateway will allow through. And it is different between the service port, but it could also be the save port. So we know for sure that 3389 is the port for RDP. We can make it the same port that the user requests. Service IP, this is the IP of the virtual machine or the physical machine that is actually running the service. So in simplest forms, this is a Windows 2019 server, say. So again, we'll just put some fake IPs in there for now for demo purposes. And then service port, this is the port that VM is actually listening to. So on the back end, if you chose to change your service port for your actual RDP server to something other than 3389, you can just do that here. So that's the port that's actually being listened to by the service. And then we decide whether or not, how we're going to actually route that. We have the capability of deploying a gateway per host, physical or virtual, or remote. Remote meaning that it's actually on a different host. So in this case, to make it look like configure like a true gateway, we'll say that the RDP service is running on a remote server. So then we save it. Now we have the ability, now we see that this trust zone is protecting an RDP server, and to actually authenticate yourself, the device to that gateway, you'd have to use this SPA port to actually connect to it. Now, once we have configured the services that we want to protect, we set up the SPA port, we've got the gateway ready to go. Now we generate the credentials. Now, what generate credential does is marshals all the information that you need to communicate within the environment. Encryption keys, certificates, default settings, all gets marshaled by doing generate credentials. Once we generate our credentials, you'll see that we have the generate credentials. Now we have the copy box available. And as I showed you earlier, the idea is to be able to very quickly deploy this configuration without very much in the way of extra work or extra copying around, et cetera. And just like I showed you before, you get a URL once you do a copy, and then once you have that URL, again, you can either give that URL to the user to enter in their browser, you can SMS it to them, or what have you. But basically, if you just copied here, you'll notice we'll get that trust zone, and the zip contains all the information that that user needs or the administrator needs to configure that gateway and finally get it online. So continuing to that's how you would define your gateways on the fly. Again, you can utilize APIs to make a bulk configuration faster instead of doing one at a time. That's how that happens. Now, the next one is users. Users, we typically tie into your Active Directory to find out what users are in the system. Again, this is a demo system for simplicity's sake. These are actually stored on our controller. So we have the capability of defining local users in our own database for use for authentication, or obviously large enterprises and agencies would want us to tie into their Active Directory or LDAP service. Devices is where, this is the part where we actually have to authenticate and onboard a device. So when you add a device, you can see here, I've actually have two set up just to give you an example of what they look like. You should see that you have the device, what trust zone it's going in, and what user is allowed to use that device. So if you want to add a new device, it's simple, just like it was for the gateways. You would add a device, you come up with a device name. We'll just say Paul's laptop, for instance. It's free text, you can do what you like. It's a Windows box. We're running 10. And then this is the critical part. We have the MAC address recorded so that we can absolutely identify that this is the device that we onboarded, this is the device we actually know. So currently we're using MAC address, but we can actually expand that to be something more unique, sort of like a UUID, like we use for our ID portion of the solution. So for completeness sake, or for easy sake, I'm just going to go ahead and put in a MAC address that doesn't actually exist. It's a laptop. Paul's the guy who's going to be able to use this thing. And what gateway do we want Paul to be able to use? Do we want to set up the new gateway, or do we want to let Paul use the gateway that's already there? We can pick it. So we said, okay, we're going to Paul to use 112, the trust zone, if you will, 112. And we're going to create a new client in the system. And we're going to make sure he's valid when he comes in line. So we just save it. And again, you can see it adds it right here. And we have the same situation as we do with gateways. Again, to facilitate setting up the environment very quickly and to lessen the muss and fuss, if you will, of someone doing this on their own, we have the ability to generate the credentials. And just like the gateways, the credential generator marshals all the information you need, encryption keys, certificates, default configurations. And in this case, we'll actually tell it which gateways it's supposed to use and what services it's supposed to have, so that the user doesn't have to do anything. Once the application is installed, they just download the configuration and start up the client, and it takes care of the rest. So once we do generate credentials, again, just like the gateway, we now have the ability to copy those credentials. And if we wanted to just show it like we did last time, just for completeness, you can see that we now get a configuration file for our new client, which has been assigned ID 113. Moving down the list, we get to our services. And services you've already kind of seen. These are where we define what services we're going to protect. And this is across the board. This is across all gateways. Again, this being a demo, this is a very small list. The first two are curious because these are the ones that are embedded in the system, so that everybody can reach our controller gateway, and everybody can use our tunnel service. Our tunnel service is important because it actually allows us to encrypt that first mile, the connection between the user's endpoint and our gateway is all encrypted. And then obviously the backend is encrypted as well. Now, this is the important part. This is where we actually define the policies that we want enforced at the gateways. So you can see that again, I've got two gateways already, two clients already set up free, just to let you see what they look like, what a policy might look like. But this is where you say, okay, Paul on client 100, which is actually client 01, I just know that, is able to get to the chat service that we have protected. Larry on client 02, which is 101, has the ability to get to a remote desktop server. And it's enabled. If you want to add additional services, you just do that here through your policy. So you edit your policy, and you'll notice that only the policies that we have defined are available. I mean, only the services that we have defined for the gateway are available. So if I were to want to add, like, say, oh, I don't know, SSH, I can add that here. We save it. Now, if Paul comes from this device and he's asking for SSH, he will be allowed through. If he doesn't have that capability, his request gets denied. It doesn't matter if he's legitimate. It doesn't matter if his client is legitimate. The policy says he can't have anything but these things, and that's all it will ever have. And then, and that's basically how you would manage a solution in your environments or even in the cloud. Again, this is available in on-premise as well as in the cloud. And the idea is that the administration console makes it easier for you to manage. I'll whip it back to you, Charles.
All right. That was a great explanation. Thanks, Paul. Next, we're going to go. So Paul just created the zero trust zone that we will be authenticating into. We're going to do a demo of access, which is scenario number 1. And Paul, maybe you can describe the scenario for people in detail and how the architecture enables that.
Absolutely, Charles. So what we showed you are pretty much high-level views of how the system works. You'll recognize some of the components on this drill-down screen slide from the earlier components that Charles introduced in the presentation. This is an attempt to show you how the basic scenario for our zero trust solution, and also the one that was defined in the outline guide, works. So essentially, every scenario works like this in some variation. So if you can just follow the steps, but I can walk you through them if you like. But essentially, you authenticate with our Resiliant ID, which is steps 1 through 3. Then you get a verdict back, whether or not you based on liveness test, bias test, and the onboarded profile will get a determination of whether or not you are authentic or not. If you are authentic, then that takes you into the zero trust part of the solution. That's where you can now send a SPA packet, single packet authentication, to a request that your device is authenticated, number 6 here, at the gateway. The gateway then asks, takes the user ID to our controller, says, okay, this guy is authentic. We know he's a real person. We know he's been proving to be alive. Is he someone that should be accessing our system? And that's what the controller checks against your Active Directory to see if it's a known user. If it's a known user, then we go ahead and we tell the gateway, go ahead and allow that connection to happen. Finally, the user makes number 11 over here that makes the connection to the RDP service or the chat service or what other services we've got protected in the trust zone. Charles will show you a quick demo, a quick video that shows how that works from login all the way to access.
All right, here's the Resilient ID secure access verification. Verifying a user with Resilient ID is a very simple process after they've been successfully onboarded With online verification, a push is automatically sent to the company login process to the user's cell phone, which will immediately prompt the user to take a selfie. Resiliant ID will examine the selfie for liveness, ensuring that no one has attempted to provide a deepfake video, a mask over the face, or using a photograph. Resiliant ID will then examine the selfie against the stored ID NFT, a blockchain-based ID which was created in the onboarding process. Once validated, the user will be granted access. For Resiliant ID online verification, again, it's very simple. Once the user logs into the company site, they will receive a push and the user's cell phone will automatically prompt the user to take a selfie. Next, Resiliant ID will examine the selfie for liveness. And well, there we are, we're taking the selfie here. Next, Resiliant ID examines the selfie for liveness and then validates the selfie against the stored ID NFT. Once it's validated, the user will be granted access into the application. And Paul, next, you're going to be demonstrating scenario number 2, the satellite office with the government furnished equipment and limited use enforcement.
That's correct. Why don't we go ahead and see that next slide? So scenario 2 is really about limited use enforcement, but we thought it was important to show you what our solution can do in this situation. Obviously, we cannot put every public internet service behind a trust zone. We don't own it. We can't stop people from routing to it. But what we can do is we have the ability of acting as a custom multi-factor authentication in the ADFS environments. Obviously, this capability allows for positive identification of the user before access is granted to federated service, such as Office 365. So here at the bottom is a very simplistic diagram of what I'm about to show you. Basically, it has the same flow as everything else, other than what we do now is we allow our ADFS federated with our Azure AD for Office 365 to then use our Resiliant ID capability as the multi-factor authentication piece, which guarantees that the user is the user that we think they are, and that the user is not being faked or otherwise being spoofed. And with that, I'll take you to a live demo of how we do that. Give me 1 second. Share my screen. So what you're seeing here is, again, my demo system, but for the sake of demonstrating the capability of Office 365, I have you in my ADFS environment. So what I'll do is I'll live share my screen for my phone so you can see the whole thing. And let me go ahead and reposition everything so you can do, so I can show you this live. So this is actually my live phone you're looking at. There it is. And then with this, what we do is we can say, okay, user, we can't protect you from the internet, but we can definitely make sure that you are the person that we think you are by 100% authenticating you with our solution. So what we can do is I'll go ahead and log in as me. You can see I'm going to the standard Office portal available in Azure, Office 365. And I'm going to log into my domain. And then click next. Now, because we're federated, Office 365 kicks it back to me, to my domain, to get authenticated. So I'll go ahead and authenticate into my domain. Now, once I'm authenticated into my domain, what you have now is the ability to, with our multi-factor capability, to use Resiliant ID to 100% guarantee that this is the right guy. So what I'll do now is I'll submit that. And what you'll see here on my phone is a push. That's the indication that I need to authenticate. So just like what Charles showed you earlier in the video, I am actually going to go through this live process for you right now to show you how it works. So now that I've actually acknowledged that I have to take a selfie, so I'm going to take a selfie. I have to go to the side a little bit, it's a little bright in there. So I'll take a selfie. There's my selfie. Now, as it's going to authenticate, and once it authenticates, we're going to automatically redirect you to your Office 365 account. So I'm successfully verified. Okay, thank you. Now I'm in Office 365. So again, we can't protect you from the internet, but we can definitely make sure that you are, if you're in a case of shared software services in the cloud, we can make sure that you are authentic and definitely allowed to do that before we allow you to do it. Now I'll kick it back to Charles for some.
Thanks, Paul. That was much appreciated. Here we have, Resiliant has created a end-to-end zero trust solution for the Department of Homeland Security. This solution is called ICAM on the fly and enables first responders to be able to onboard in their home state with their certifications, whether they're a firefighter or a welder or someone with specialties that have been certified for those, and then to be able to go to any disaster in the continental United States and report to an incident commander, the incident commander managing the local disaster. The incident commander, once having a incident responder report to them, is able to verify the incident responder utilizing our ICAM solution. The incident responder, upon approaching the incident commander, takes a selfie. It verifies who they are and that they are who they say they are. It produces, in this particular application, produces a QR code. And that incident commander is able to read that with a Resiliant reader, and thereby transferring all the incident responders' credentials that he has created with his onboarding process back in his home state. And all those credentials are now transferred to the incident commander and immediately allowing the incident commander to deploy the incident responder to a specific task that they have certifications for. This eliminates any type of activity that has taken place previously where individuals were trying to sneak into disasters, either to steal, but it also, what this does is it provides the incident commander the immediate ability to be able to deploy incident responders to situations with the proper credentialed individuals, the proper credentialed incident responders. We have installed our product at Texas A&M, and it is utilized within their disaster city operations, where they train incident responders throughout the United States on a regular basis and are trained on the use of our system as well. Finally, we're looking for partners. We're looking for integrators. We're looking for vendors who are focusing in on pillars 1 and 2, the ICAM portion. And they want to be able to add a zero trust capability, zero trust zones to their solution. Also looking for vendors focusing on pillars 3, 4, 5, 6, and 7 that may want to add a strong, robust ICAM solution to their current solution. And we want to thank you for your time and consideration. Any questions regarding our presentation today? Well, I think that may be the extent of the presentation for today. I don't see any questions. Chris, do you see any?
No, I don't see any.
Okay.
Just a couple comments. Just great job and thank you.
All right. Well, appreciate the opportunity to present to the ATARC group.